Hey guys, welcome to another Science on the Porch. Today we are going to talk about vaccines, and we have a lot to get through, so I'm gonna try and go fast. To start, we gotta go back to the 1700s when smallpox was rampant, literally small pockets, because there were like small pockets of pus on people's skin. This disease was terrible, okay? Like 400,000 people died annually. Like 1 in 3 people who were infected died. It was spreading, through people's breath, through touch. It was spreading because, people were starting to travel. So before vaccination came around, people did something a little similar called inoculation. So basically what that was taking the scabs of someone who was infected with smallpox and then taking them and putting them into like a cut of somebody who was not infected. And so as a result, that person would get a less severe version of the disease and build up an immunity to it. Guys, it is like really hot out here. That's why I'm wearing my smoky shirt. Taken into account during this time, people didn't really know what viruses were. They didn't know about bacteria. This was all just kind of speculation. However, what they did know was that if someone had the disease once, they didn't usually get it again. And they also noticed that milkmaids didn't get smallpox. So this guy, Edward Jenner, he's like, okay, milkmaids don't get smallpox. They get cowpox because they're milking the cows. So what he did was he took a scab from a milkmaid infected with cowpox, and he took that and then put it into an 8-year-old boy, and that boy was then immune from smallpox. This was the first vaccine. He coined the term vaca, means cow. And as a result of his efforts, smallpox was eradicated in 1980. All right, so how do vaccines work? Well, there are different types. There are like all these different ones, but basically for these traditional vaccines, the point is to take a weakened virus or bacteria or a dead one and basically introduce it into our body so then our body can build up an immune response to that weakened or dead virus. So then when we encounter the actual virus in the future, our body's already prepared to fight it. So what's going on with COVID? Like, why don't we have a vaccine yet? Why does it take so long to create a vaccine? Well, in all honesty, this is the quickest a vaccine has ever gone through production. We have like 30 vaccines already in phase 3 trials, which is unheard of. The quickest we've ever created a vaccine was in 4 years, and that was for mumps. So you might be thinking, wait, we have a new flu vaccine every year, so how do we do that? Well, we already basically have the sequence of the flu. And to be honest, we make the flu vaccine a year in advance. So that's why the flu vaccine has an efficacy rate of 40 to 60%. That means that it stops infection or lowers infection by 40 to 60%, meaning it's not perfect because basically scientists guess the most likely strain that will be prevalent in the next year based on how it's evolved over the years. There's a lot of misconceptions about vaccines, meaning like if you get a vaccine, you won't get the disease at all. And that's not true. Sometimes you get the disease, it's just you don't get it as bad. So you have the flu for like 1 day instead of 3 or 4. So how is this COVID vaccine already in so many human trials? How did we speed up this entire process so fast? Because usually it's this. Like you have to figure out what the prototype, you have to do the DNA sequencing of the virus. You need to figure out what protein that you need to attack on the virus, to build up immunity. And then you have to go through animal testing. And then you have to go through phase 1 trials, which is a select group of people. And then phase 2, a little bit more people. Phase 3, even more. And then after that, then you have to get approved. And then you have to go through mass production. And then finally it gets to the public. So the first case of COVID was like December or January. But within a week, the entire genome sequence, because of our new gene editing technology, it was already out on the internet within a week. So scientists got the code Friday night, Monday morning, went to the lab. They're like, all right, let's do this. The other thing about COVID is that because it is a coronavirus, it's not the first coronavirus we've seen. So the protein that we're looking to kind of pinpoint that virus and build antibodies against, we already know the sequence of that protein. It's the spike protein that looks like the little crown, which is why coronavirus is named corona, meaning crown. The vaccines in production in the US that's worth mentioning is an mRNA vaccine. This is the newest kind of vaccine. There are no mRNA or DNA vaccines approved for humans yet. There is one approved for horses. What makes this vaccine different? Well, instead of having a dead virus or kind of an inactive virus being injected into someone to build an immune response, they take the mRNA sequence and they kind of give us that genetic material, which then encodes for the protein that fights the virus. So in other words, it's not giving us the virus itself, so our body creates an immune response to it. It's giving us information so our body creates the correct antigen, which creates an immune response for the virus, without the virus even having to be there. So the biggest challenge that we have with COVID is once we get this vaccine out, which we will, realistically, it won't be for another year, like next summer. But when we get it out, the biggest challenge will be distributing it to 7.5 billion people, because that's what we'll need to eradicate this virus. And that has never been done before. The most that we've ever distributed vaccine was for polio, which was 500 million doses in a year. We need 7.5 billion doses. And I mean, experts are working on this, even the little glass vials that the doses come in, like, are there even 7.5 billion of those available? The goal that scientists have now is to have 1 billion doses available in the first 6 months. So then 1 billion, it's like, well, who gets vaccinated first? Obviously, number one, healthcare workers, but then, who after that? So, a little bit to think about here. I just want to throw in some vaccine fun facts. Fun fact number one, there's no link between autism and vaccines. Fun fact number two, some people are wary of toxins in vaccines. There are some toxins. However, formaldehyde, there's 0.1 milligrams tops in a vaccine. And if you eat an apple, it has 1 to 6 milligrams. So a lot of these toxins people are scared of are already naturally occurring in our food. Same with the mercury that people are worried about. Now, there's no mercury in vaccines at all, except the flu vaccine. But this mercury is ethyl mercury. And again, super small amount, and it's not even the same mercury that we worry about with mercury poisoning in fish. That is methyl mercury. Vaccines are one of the greatest medical advances of all time. They've saved hundreds of millions of lives. And if you guys could just pretty please get your flu shot, like, as soon as you can, it would really help medical professionals with all the stress that's been put on the hospital system since COVID. So just get vaccinated.